Okay, so welcome to section 1.3, truth tables. Truth tables. Actually, I don't like the way that's written. Let me write that a bit better. So, truth tables. Okay, so let's recall from our previous section the union and intersection. So A, let me draw this a bit better. A and an upside down U, and B is the equivalent to A, and an upside down V and B, which is what? It's A and B. And B. And if I had A with an actual right side up U, B, well, that's the same to A and a right side up V, B, which of course is A or B, right? And remember, for the A or B, we say either A or B. That'll help us out. So, for example, so let's let A be the statement, I like math. I like math. And B be the statement, I like English. Okay, so let's translate the following. Translate the following. So number one, let's say I like math or English. I like, and in fact, let me make it more obvious. I like either math or English, or both, right? I like either math or English. English. Okay, so let's call A blue. I like math. So that would be I like math. Oops, let me draw that a bit better. I like math is the A, so that's the A. And either or, we know is the or, so that's the union. Let's have B, I like English. So that would be I like, and then English, right? So I like math or I like English, A or B. Okay, so number two, let's say I like math and I like English. So I like math and I like English. And I like English. Okay, so once again, the I like math is my A, it's the blue. However, this case we're saying and. So the and is the upside down U. And of course, the I like English is still my B. So the intersection of the two sets, I like math and I like English. So let's go back to that little not symbol we had before. So I do not like math. So we do have the I like math here. Here's my I. Here's like math. So that's my A. But I have this do not here. That do not, remember, was this symbol, not the set. So I do not like math. Number four. Let's say I don't like math or English. So I don't like math or English. Okay, so how would I write this? Well, I like math here. Or English, right? So or. Let's do the V this time for the or. Not that it matters. Oops. Okay. Move this down a bit. So I like English is B. However, I have the don't. So I have to negate this whole thing. I don't like math or English. Why are these? And we'll find out later that that's equivalent to saying I neither like English nor do I like math. So now let's actually get to what this section is all about, and that's truth tables. So let's consider the following. So we're going to consider two objects, A and B, that can either be labeled true or false. So two objects, capital A and capital B, that can either be labeled labeled true, capital T, remember we're using capital T for true, or false, capital F for false, right? Okay, so let's call A blue, and let's call B purple. So the first scenario would be, let's see, let me put it down here, that either A is true and B is true, right? So true and B is true. Another scenario would be that A is true and B is false, right? A third scenario would be maybe A is false this time. And maybe B is true. And the only remaining scenario would be when A is false and B is also false. So these are the four possible scenarios here, right? Given two objects that can either be true or false. These are the only four ways I can have this. Either they're both true, either the first is true and the second is false, either the first is false and the second is true, or either they're both false. Okay, so this is how we're always going to set things up. But let's note something important. So note, when I negate something that's true, so something that is not true is false. Similarly, something that is not false must be true. So when we negate a true or false statement, we get the opposite. Okay, so I want you to notice something. The grouping here. I have two trues. Oh, wow, I don't really like. Let's see if I can make this a bit better. Nope, is it gonna let me? Nope, is it gonna let me do anything with this? Nope. Okay, let me just delete that. Okay, so notice I have two trues and two falses here. And this one, the B alternates true, false, true, false. So I'm always going to set things up this way. It's just easier. So A will be true, true, false, false. And B is going to be true, false, true, false. So theorem. So the truth tables for A or B and A and B are as follows. So the truth tables, and I'll show you how we fill this in, for A and B, or A or B, and I'm using the V's this time, doesn't really matter, are given by. So what we're going to do is we're going to have a table here. So I'm just going to do something general like this. So I always give myself at least 4 possibilities. So here's my A. That is true, true, false, false. And you know what? Do I have enough room to skip? Let's see. So true, true, false, false, just barely. Yeah, so maybe I should move that up a bit. So let's go true, true, false, false. Okay, there we go. So I always start A, true, true, false, false, and I always alternate B. So B is always true, false, true, false. Okay, so now I would like to consider A and B. So A and B. So they both have to have the same truth value. Both A and B have the same truth value. Well, let's look at this. A and B. So true and true is always true because they both have the same truth value. True and false, that's false. They're different. They're both different. False and true, that's false. They're both different. False and false, well, they're both false. So they're both false. Okay, so that is the truth table for and. What about or? So A or B. So either A is true or B is true. We don't need them both to be true. Now it's either or. Okay, so let's look at, we're looking right here at the first 2 guys here. So true or true. Yes, that's definitely true. Second guy here, true or false. Well, at least one of them's true, so that's true. Third guy here, false or true. Well, one of them's true. The only time the or is false is when we don't have an option to have either or being true. Okay, so now I'm going to, let's go ahead and tack on a couple more. Let's do not A. So the negation of A, when we negate true, we get false and vice versa. So the negation of true is false. The negation of true over here is false. The negation of false would be true. And the negation of false would be true. So this would be not A, the negation. Okay, so now let's look at not B. If I were to negate B, what would that be? Actually, let me write that in a different color purple, the lighter purple. Okay, so not B would be following. Oops, okay. What's going on here? Come on. Just want to fill in this blank. Okay, so not B. So true, the negation of true is false. False, the negation of false is true, etc. False, true. So that would be not be. Okay, so definition. Okay, so remember the conditional statement? If P, then Q. Hello, kitty. So in the conditional statement, if P, then Q, the first definition is P. P is the antecedent. The antecedent, like antebellum, right before. Antecedent. And number 2, Q is the consequent. Q is the consequent. Okay, so that's the formal nomenclature for the conditional statements. So now let's deal with related statements to the conditional statement, if P, then Q. I think I prefer it that way. Okay, so these are called the related statements. So related, how are they related? We will see. So related statements. Okay, so the first one is called the conditional, and that's the one we're used to, right? The conditional. Conditional. And that, of course, is if P, then Q. And of course, we know this as P, oops, wrong color. This is P with a right arrow to Q. That's if P, then Q. Right, so let me go ahead and put a box around this. If P, then Q. That is the conditional statement. So the next statement is called the converse. Converse. So the converse is given by if Q, then P. So if Q, then P. Well, we know how to do the if, then. It's a right arrow. So this would start with Q. Let me draw that a bit better. And it would have a right arrow pointing to P, because this is if Q, then P. So that is the converse of the conditional. Oops, okay, come on. There we go. Okay, so the next related statement would be the inverse. So the inverse is if not P, then not Q. So if not P, then not Q. Okay, so this would be, we know it's going to be related by an arrow, of course. But we have not P. So if not P, then not Q. So this is the inverse. Actually, I probably could have made this arrow a bit smaller. Push this a bit closer to there. Maybe cut that a bit. Bring this a bit closer. How's that look? That looks a bit better. Okay, so actually, bring this a little bit. There we go. So if not P, then not Q. So what's the last possible related statement? Would be not Q. If not Q, then not P. All right. So, and that's called the contrapositive. So contrapositive. So that's if not Q, then not P. Then not P. Okay, so this is what we think it is. So not Q. And I'm going to use a word that I haven't yet used. I'm going to say implies. Not P. Because the if then can be said more concisely as P implies Q. Oh, really? Why will it not let me draw a square around here? Okay. Okay, is that good enough for government work? Hopefully. Okay. So let me note that, what I just said, which was note P, right arrow Q, can be truncated verbally. Truncated. Oh boy, I don't know if that's correct. Can be truncated verbally to P implies Q. Implies Q. So I might be using the P implies Q as opposed to if P then Q, because sometimes it's more concise. So for example, let's illustrate the related statements. So given the conditional statement, conditional statement, if I wake up, then I will eat. So if I wake up early, then I will eat breakfast. That sounds better. So then I will eat breakfast. Okay. So let's call P I wake up early, right? So P is I wake up early. And of course, Q would be I will eat breakfast. I will eat breakfast. Okay, so let's see what we have here. What's the converse? Well, the converse, of course, is Q implies P, right? Oops. Q, right arrow, P. That's the converse. Q implies P. Okay, so how would I state this in English? Well, this is stated if what? If I eat breakfast, and I can change the English a bit to work, then I'll wake up. So this would be the converse, right? Q implies P. What about the inverse? of the conditional. So what was the inverse again? Not Q implies not P. So that was not, no, sorry, it was not P implies not Q. What am I saying? So not P implies not Q. That's the inverse. Okay, so not, so it's still an implication, so it's still an if then. So if I don't wake up early, so if I don't, because I'm negating, don't wake up early, then, because it's conditional, if then, what's my cue? Then I won't eat breakfast, right? I won't eat breakfast. So that's my not cue. So if I don't wake up early, that's my not P. Then, that's my implication, I won't eat breakfast. So the last one is the contrapositive. And this is, let's take a look at the contrapositive, which is not Q implies not P. So not Q, if not Q, then not P. So not Q implies not P. Not P. There's something interesting about the contrapositive. So translating, this would be if I don't, because we're negating, don't eat breakfast. Don't eat breakfast. Then I won't wake up early. Okay, so just ponder that for a moment. So if I don't eat breakfast, then I won't wake up early. What was the conditional statement? If I wake up early, then I will eat breakfast. Sounds like there's raccoons in my garage, because there probably are. Okay, so moving on. So definition. So the truth table for the conditional statement, P implies Q, is given by. So the truth table. Truth table for the conditional statement, P, right arrow, Q, is, so let's just go ahead and state it. P, Q, and their implications. So actually I don't need a lot here. Okay, so let's have P be the first guy, which is always true, true, and then false, false. Let's have Q be the second guy, which alternates true, false, true, false. Now we want the implication or conditional. P implies Q. Actually, let me stick with yellow. So if P, then Q. Oh, actually, it's supposed to, isn't Q supposed to be orange? Yes, it is. So let me redo Q in orange. Okay, so Q is in orange. True, false, true, false. Okay, so P implies Q, or if P, then Q. Well, let's think about this. Does something true imply something true? Yes, if I have a true statement, if a true statement, then a true statement, that's true. Can something true imply something false? No, actually it can't. So I'm going to put this as an F in red. However, something false implying something true actually is a true statement. And finally, something false implying something false, well, false implies false is also true. So the only false, this is the only false, only false. So true cannot imply false. Something true cannot imply something false. Okay, so let's see an example. Okay, so let's create a truth table for the 4 related statements. So create a truth table for the 4 related statements. 4 related statements, and that's all I will do for this section. So related statements. So what were the 4 related statements? Well, the conditional, the converse, the inverse, and the contrapositive. Okay, so let's start with P and Q. Let's see. And P implies Q. So we have P, which we know is true, true, false, false. And Q, which alternates. Why do I always do Q in purple? So Q, which goes true, false, true, false. And now let's do the conditional statement. P implies Q. And we know that the only time an implication is false is true cannot imply false. So I'm just going to go ahead and do that right away, right here, so that I know everything else is true and I don't have to think. True, true, true. So this is the conditional statement. So what's the converse again? Q implies P. So actually, maybe I should just copy and paste. That might be easier. Let's copy this whole thing. Copy, paste. So I'm going to redo this. And now instead of P implying Q, what was the converse again? Q implies P. Delete. Okay, so the converse is still an implication, but it's Q implies P. So in this case, it might have been easier for me to not copy and paste. I probably should have done Q first and then P second. So why don't I do that? I'm going to swap the order. I'll write Q in the first column and P in the second column, but I'm going to keep the arrangement of true and false the same. So that is, Q is going to alternate. True, false, true, false, true. Why is this off kilter? What's going on? There we go. Technology. Okay, so true, false for Q, but P is going to be true, true, false, false. So it's still the same P and Q. So I know for this one, the implication has that true cannot imply false. So this is the only false for the implication. Okay, so what was this again? This was the conditional. Right here. The next one was the converse, right? Q implies P, so this is the converse. Do I have enough room to put one more beside it? Maybe I'll put it beneath. Yeah, I'll put it beneath, but let me copy and paste again. Or should I? Maybe I'll just rewrite it. Okay, so the next one would be what? The inverse, right? Not P implies not Q. So let's do our P's and our Q's, but this time I'm going to need an extra couple lines, right? Going to need not P and not Q, and then I could do my implication. Okay, so let's see what we have here. So P is true, true, false, false. Q alternates. Why do I always use purple? I knew it's orange. So Q alternates true, false, true, false. But now I want not P. So not P is going to be the opposite of what P is. So false, false, true, true. Similarly, not Q is going to be false, true, false, true. So now when I have the implication, not P implies not Q, and I need more room. Implies not Q. The only time it's going to be false is when true implies false. So it's only going to be false here. Everything else, of course, will be true. Okay, so now that was what was that called again? The inverse, right? So I have the conditional, the converse, the inverse, and what's left? Well, that would be the contrapositive. So do I have it? Yeah, I guess I don't know if I have enough room to do that beside it, so I'll do it underneath. So the next one would be the contrapositive. So once again, P, Q, not. Actually, what is the contrapositive again? The contrapositive was not Q, implies not P. So in this case, I'm going to go ahead and do Q first, which is true, false, true, false. Then I'll do P second, which is true, true, false, false. So now when I do not Q, I negate what Q was, so I get false, true, false, true. And when I do not P, I just negate P, so it'll now be false, false, true, true. So the implication, not Q, implies not P. What does that give us? Well, the only time this is false is when true implies false. So that would be in the second case. Everything else is true. True, true, true. Okay, so that was the contrapositive. Contrapositive. Okay, so let's look at these truth tables. So for the conditional, the false is in the second place, as it is for the contrapositive. So what's interesting is that the conditional, what's the conditional again? P implies Q. It's actually equivalent to what? The contrapositive, which is not Q. Let me use equivalent. Yeah. So not Q. Why do I keep on using purple? It's like I don't know how to not use purple for Q, because I'm so used to using purple for Q, but in this section I used orange. So I gotta stick with it. So not Q implies not P. So the conditional is equal to the contrapositive. So conditional is the same as contrapositive as far as the truth table is concerned. Contrapositive. Well, is the same, do I have the same relationship between the other two? Well, it looks like the other two, the converse and the inverse, both have false in the third place. So yeah, turns out that the converse, Q implies P. So Q implies P. Is the same as the inverse. What's the inverse? Not P implies not Q. Well, if I swap the variables, it should be obvious that these are exactly the same. The logic follows as what's above it, not Q. So what was Q implies P again? That was the inverse, right? So, no, the converse is equal to the inverse. Get it right. Converse is the same as the inverse with respect to its truth table. Okay, I know this was a lot, so I will see you in the next section. Oop.